Does coffee make me more productive? Most of us would answer this question just by getting a cup of coffee, drinking it in the morning, and seeing if we feel better about this. In this video, we're going to go through some of the key concepts from chapter 2 to see how a scientist would start analyzing and trying to answer that question. The first problem with my method is that I lack an operational definition of what it is to be productive. Does being productive mean showing up to work on time? Does it mean not going on Facebook? Does it mean bringing my boss lunch if I'm late from lunch? And then the next problem is going to be the placebo problem. When I drink a cup of coffee, I'm going to be expecting that I am more productive that day. And it might be that expectation or that belief that causes me to be more productive and not necessarily the coffee. So I might instead decide to get a bunch of mice, feed them some caffeine, and look at their behavior. Do they run faster on wheels? Do they go quicker through mazes? Do they solve some other problems better than other mice? The problem is that this is going to face a problem of external validity. People are quite different than mice. A mouse might respond by walking faster or running faster on this little wheel. I might respond by getting so much courage that I think I can win an argument on Facebook, and that's going to, of course, lower my productivity for the day. So I might instead try asking my peers, do you drink coffee and does it help? And they're going to say yes. But then we're going to have an observer bias problem. The caffeine junkies are going to swear that it makes them more productive because that's what they want to believe and that's what they expect to believe. So that is an illustration of a problem with internal validity. I can't know whether the observation or the hypothesis applies to the population I'm studying. So what I can now do is try to get some controls. I get two populations of individuals, and one of them gets caffeine, one of them gets decaf, but they don't know which one is which, so that we eliminate the observer bias. We randomize so that there's equally amount of people on both sides. So if there's caffeine lovers on one side, there's caffeine lovers on others. If there's caffeine haters on one side, there's caffeine haters on the other. And so the biases will cancel each other out, and we just are looking straight at the effect of caffeine. And we try to make sure we get a large enough sample on both sides.